Dear students, today we are going to learn Unit 3, and in this unit, you are going to learn machine learning algorithm, that is decision tree. So, in whole unit, you are going to learn decision tree in more depth. So, all the concept of decision tree, you will be familiar at the end of this unit. Already, you know from DSA what do you mean by tree. So, tree is representing the hierarchical structure. At the base of the tree, root should be strong. Now, tree will start from root only. Then from the root, the branches are going to be developed. And again, to these branches, you will have the leaves. So these are all the concepts, the same terminologies you are going to use in decision tree. Now, question comes to our mind whether it is supervised learning method, unsupervised, or semi-supervised. So, decision tree is making use of a labeled data set, hence it comes to the category of supervised learning method. It is used for both classification as well as regression, and it will help you for decision making. Now, as I have shown the tree in the reverse order, always you should start from root. Now, the first concept is when a situation is given to you, using decision tree, you should be capable of representing that situation. Means you will ask a question, so you will get the root. Now, that question will have some possible answers. So, those answers will generate the branches to the subtrees. So like that, the tree will go on progressing from root node to the internal nodes to the leaf node. And finally, in the leaf node, you will have the prediction that you are expecting from decision tree. So this concept of developing your decision tree from root to the internal nodes to the leaf node is called as induction into decision tree. And as you are repeating the same process, that applying some condition or asking some questions and going to the branches, splitting your data, and again repeating the same process in these nodes also. And again, you will have some branches of these nodes. So as you are repeating the same procedure from root node to reach to the leaf node, so it is called as a recursive induction of decision tree, and which will finally give you a tree-like structure. Now, from the diagram, it is clear that root node is one of the decision node, and then from root node, you are having two possible choices. Then you will get your left subtree and the right subtree, and again in this internal node, some decision will be taken, and finally you will reach to the leaf node, and which is known as a best predictor. Now, if your labeled data set is showing me only two classes, then it is a binary classification. And if your labels are belonging to more than two classes, then it is multi-class classification. Now, here, decision tree is expecting at least two branches when it is a binary classification. And when it is multi-class classification, each node will have more than two branches, and leaf node is showing you the final classification. Now your decision tree is capable of handling both type of the data, categorical data as well as numerical data. So these are all the properties of decision tree you should remember when asked in exam, and this is the basic structure of the decision tree that you should be able to draw, and one example you should show. Okay, more and more example you will see in upcoming slides. Now, a question is asked to me whether I'm hungry. If not, directly I can go to bed and sleep. If yes, then I should have some food. Now, for purchasing the food, I should have enough money with me. If I'm having $25, then only I can go to the restaurant and buy food and enjoy in restaurant. If I'm having less than $25 with me, then I can buy only a burger and satisfy my hunger. So a situation is given to me, and with the possible options, I'm converting it into a decision tree. So this is what representing a concept using decision tree. So one more example. Question is asked me, should I accept a new job offer or not? So your decision tree is what? It is a graphical representation of all the possible solution to reach to a decision. It will help you for taking a decision. Okay. Now, add job means question come to our mind. What is the package? So my expectation is salary should be at least $50,000. Now, so to this question, there are two possible answers, yes or no. When the answer is no, I will simply decline the offer. When answer is yes, I will see that how much is the traveling time from my residential place to the workplace. If it is less than 1 hour, then only comfortable to me. If it is yes, more than 1 hour, then in that case also I will decline the offer. If it is less than 1 hour, then next my condition is whether company is offering me free coffee or not, because I'm addicted to coffee. Without having coffee for every 1 hour, I can't work. Then if company is not offering me coffee, again I will decline the offer, and when it is offering, then only I will accept the offer. So at the leaf node you can see that either I am having accept offer or decline offer. So this is my final prediction. And as you can see that there are two options, accept or decline, means it is a binary classification, and even each node is having only two branches, means binary classification. Now, one more example. Huffman code is given to me and I have to represent it using decision tree. Then, these are the classes for my Huffman code. Now, I will start from the root node. Now, root node will proceed only with two options, 0 or 1. When it is proceeded with option 1, then I will reach to a class which is expecting only the value 1. Now, when it is starting with 0, then it may go to one more 0 or 1. Now, when it is going from 0 to 1, then again it is giving me one more class, that is C. But if it is going from 0 to 0, then again it will have two options, 0 to 1. Now, when it is going from this 0 to this 0 to this 1, means what? 0, 0, 1. Then in that case, I will go to which class? B. Now, when it is going to third 0, means all the zeros, then it will give me the class A. So like this, I'm capable of representing Huffman code using decision tree. Now, this dataset you can take as an assignment and convert it into decision tree. You can see that it is a loan approval prediction dataset in which the features are, I'm considering the age of the person, whether he is having job or not, whether he is having own house or not, and what is his CIBIL score, that is a credit rating. And based on that, whether the loan will be sanctioned or not, yes or no. Only these two options I am giving. Okay. So take it as an assignment and try to construct the decision tree. Now, what you should remember is generally while constructing a decision tree, you are splitting your data, means you are forming a subset of your data points. So those subsets are known as a homogeneous region. From this diagram, you will understand that how I can form homogeneous regions by partitioning the data. Okay. Now what you can observe here that all the data points of same color are put into one region. Now, sometimes what happen is one of the data point may be of a different color. Then in that case, I will go for majority. Okay. So this is what a decision tree is doing. It is trying to put the similar data points together in one subset to form the homogeneous region. Now, how I can put the condition for this homogeneous region? I will consider a feature x1. Now, by vertical line, the x1 is having the value which is greater than 3 and less than 4. Means here it is. So what will be my condition? Whether x1 is greater than 3.5 or not. So the possible answers are yes or no. Okay. So these are the possible answers. Now, when the answer is no means I will consider this part. And when the answer is yes means I will consider the right side part. Okay. Now, one more feature I'm taking, that is x2, whether it is greater than 2 or not. So what this question will have, again two options, yes or no. Now, when yes is satisfied means what? I will get this region. When no is satisfied means what? I will get the red region. So the same is the output. Predict red or predict the green based on your yes or no. Now, what happens is, what about this part? These three regions are predicted correctly, but here we are having the mixture of the data. Then again, one more condition I should apply here, and that is what x2 is greater than 3r. Means when x1 is greater than 3.5, I will check whether x2 is greater than 3r. Now, when the x2 is greater than 3, then I will predict it as a red, otherwise it will be predicted as a green. So when a test point is given to you, here is the test point. Now, which condition will be satisfied? First, I will check from the root one. That is, x1 is greater than 3.5. Yeah. No, it is less than 3.5. Means it should travel the left subtree. Now, in the left subtree, again, I will check whether x2 is greater than 2. Yes, x2 is greater than 2. Means I will travel to the right subtree. So, like this. Okay. So, it should travel from the left to the right. So what it should be predicted as a green. Okay, so it is predicted as a green. So only two comparisons are enough for me to do a particular prediction, which is not possible using your nearest neighbor algorithm, in which I have to do much more calculation to calculate the Euclidean distance between the data point to make it belong to one particular group. Okay, so that is what the main advantage of your decision tree. Now there are some parameters that you should consider when you are developing your decision tree. Means how many internal nodes and leaf nodes you will allow. Then what is the branching factor? Means how many branches, how many child nodes a particular node will have. Then what is the depth of your tree? And just by applying a simple test, are you splitting your data points and whether your leaf node is capable of predicting your data in supervised manner. So these are some points that you should remember when you are constructing a decision tree. Okay. Now, generally what happens is when you are splitting your data, you should see what is the entropy of your data. Remember the terms entropy and information gain when you are splitting your data. In upcoming video, we will see a very clear formula of entropy and information gain with a particular example so that we can understand more clearly. Okay. Now, when your data is uniformly distributed, means what? More randomness is there, more uncertainty is there. Then in that case, it is called as a high entropy. High entropy means what? Less purity. Now, when your data is non-uniformly distributed, means not randomly distributed, it will have less uncertainty, it will have less entropy, and it will have more information gain. Okay. When it is high pure means what? It will have more information gain. Then only you can consider that attribute as a splitting attribute. Okay. Now, why I should use decision tree? Our human brain is taking decision by constructing such trees only. Okay. So decision tree is replicating human brain. It is replicating human thinking ability, how a particular human being is taking a decision. Okay. And it is very easy to understand because it is a graphical representation. It is a flowchart like structure. It is a tree like structure. Okay. Simply by following the path from root node to internal node to the leaf node, you can reach to a particular decision. You can reach to a particular prediction. That's why decision trees are easy to understand, easy to implement, and useful. Okay. So what we have learned in this video is how you can represent a given concept using decision tree and what are the terminologies of decision tree. So in upcoming video, we will see what do you mean by entropy and information gain. Thank you.